Professor Bialis here. In this video we're going to talk about section 6-7, the last section of chapter 6, where we talk about quadratics and problem solving. Problem solving is really just the author's fancy way of saying word problems. Now, word problems typically give a lot of people anxiety, a lot of stress, because this is not an easy part of mathematics. However, without these word problems and applications, the other stuff we do is completely useless. Okay, those sections building up to this were giving us tools and methods to solve these equations. Now we're going to put some meaning behind those equations and see how they can be utilized to find information in a real life situation. Now, a couple things I want to say right off the bat here, since this is the first word problem section for 098 students and also in chapter 6. One of the first things that we have to do with any word problem is understand the problem. That honestly is where a lot of students lose their cool, so to speak. They read a problem and then they say, well, I don't know what it said, and then they just give up. Okay, no one expects you or anybody else to be able to read a problem, write down the equation, solve it, boom, 2 seconds you're done. That's not the point of this. Okay, you may have to read a problem 5, 6 times, and don't be, I'm a slow reader. I personally am a slow reader, and I can get through these problems very, very quickly. Okay, these are very short problems. These are not page-long problems where you have 3 paragraphs to get through. You may have 3 or 4 sentences to get through. Nothing more than that, and some of them are even shorter. So don't be afraid to read them again and again. The first time you read a problem should be just to see what they're talking about. Are they talking about numbers? Are they talking about a certain shape? Just get what's the theme of the story. Read through it once or twice just to get that. And that's what you should be expecting to get out of it. After that is when you read through it, a third, fourth, fifth time where you pull that specific information out. Just take your time and be patient with it. Again, no one should be able to look at a problem or will be able to look at a problem and answer it right off the bat. Okay, so please take your time with it. If this is something you've struggled with your entire life, as I've said in previous videos, I don't care. And you shouldn't care either. This is your fresh start. Give this a shot. Okay, if you couldn't get it 5, 6 years ago, you're a little older now, so give it another shot. Okay, sometimes it just takes that time to pass for you to see what's really going on. Okay, the other thing is some of these applications, as with any math book, any math class, you're going to read them and say, who would do that, or what kind of stupid scenario is that? And some of them are not meant to be, you're applying it on a day-to-day basis in your job. These are just very simple run-of-the-mill scenarios to help you see how these problems can be organized and then solved. We're not trying to train you to find the how long it takes someone to fall necessarily off of when they jump and dive into some water. We're not necessarily, okay, we're building something and we have a width that's twice this and height that's 3 times that. You wouldn't necessarily do that all the time. However, if we can learn to organize our thoughts in these types of applications, when you do have something that applies to your nursing career or your pharmacy career or your business career, you're going to have that organizational pattern in your head that you can call upon and utilize in other scenarios. Okay, so keep that in mind as we're going through these. The examples I'm going to go through in this section are found in the textbook, and they are the practice problems. There are going to be a bunch of example problems listed there that are worked out for you, but then right after that is a practice problem that is just like the example but not worked out. So that's what we're going to do in this video is see how those play out. Okay, the first problem that we're going to talk about is practice 1, and it is found on page 427 in the book. It says, cliff divers also frequent the falls at Waimea Falls Park in Oahu, Hawaii. One of the popular diving spots is 64 feet high. Neglecting air resistance, the height of the diver above the pool after t seconds is h equals -16t squared plus 64. Find how long it takes the diver to reach the pool. Okay, when I read through it that first time, I'm not trying to get everything down in my head in one shot. There's too much information there. All I want to know is, what are they talking about? And in this case, they're talking about a cliff diver standing on a cliff, jumping off into the water. End of story. That's all we want out of that first read through, maybe even 2 read throughs. Now we go back in and try to get the information out that we need to solve the problem. So it says again, cliff divers also frequent the falls at Waimea Falls Park in Oahu, Hawaii. We already know that. There's cliff divers. Cross that sentence out. You don't need to read it again. Then, one of the popular diving spots is 64 feet high. Remember that. It's 64 feet high. Neglecting air resistance, the height of a diver above the pool after t seconds is h equals negative 16t squared plus 64. Aha, they gave you the equation. What makes word problems so hard is that you have to make the equation to solve. But in this case, they give you the equation. They specifically say the height of the diver above the pool after t seconds is negative 16t squared plus 64. They gave it to you. Okay? If this was a physics class, we would be building that equation ourselves. Okay? Remember that 64 feet high cliff, or foot high cliff? That's the 64 right there. If you've taken some physics classes in the past, you should recognize this. This is the acceleration due to gravity when an object falls. Okay? But we don't have to worry about that right now. They gave you the formula. You just need to work this out. Now, this is not all we need, because we have 2 unknowns that can't be solved with only a single equation. So let's go back to the problem. It says, find how long it takes a diver to reach the pool. Now when I reach the pool, I'm hitting the water. I'm not above the water at all. So my height above the water when I hit it should be 0. And now I have something to solve. Okay? Now, like I was saying before, don't look at this problem and say, well, I'm not going to calculate some person diving off of a cliff. That's not the point. The point of this is to give you a scenario where we have a known formula applied to it. Okay? When we're given an equation, use it. Now notice, we had to still fill in some information there. They had to give that to us, but we had this at our disposal. Okay? So when you see something like this, jump at that. Don't just look at it and say, well, I don't know what that means. Okay, write that down and then try and pull the information out of the rest of the problem to fill in the unknowns. Now we need to solve this. Okay, we go back to the whole idea of solving a quadratic with factoring. So, let's do that. We got the 0 on one side. After that, I'm going to take out a GCF, which in this case would be a negative 16. And I've got t squared, minus 4. Let's just double check that. Negative 16t squared plus 64. Perfect. I'm not done factoring. I've got t plus 2, t minus 2 with that difference of squares. Now I can solve. Okay? This 0 is never going to come from the negative 16, so I set it equal to the t plus 2 and the t minus 2. I subtract a 2. And here I add a 2. And here are our 2 answers. Now, we should expect 2 answers from a quadratic. Here's the issue though. Okay? One of these is garbage. Okay? It's what we call an extraneous solution. It's just an extra byproduct of the process. The one that's extraneous is that negative 2. The reason for that is because we just found a time. Can we have negative 2 for a time? No. Negative doesn't really apply to the time arena. So what we have is simply 2 seconds. It will take that diver 2 seconds of falling before they hit the water. Now, one thing I want to say about this, why are we getting that? Are we doing something wrong? No. When we have a quadratic, what's really happening here is we have a cliff, and we have a diver standing there, and then they jump off the cliff into the water below. Okay, that's what's really happening. But the model we used, this right here, is modeled with what we call a parabola. Okay, if we were to graph this, which we will get into a little bit later, okay, when we graph a quadratic, we will get a parabola here. The 2 and negative 2 are coming from what's really happening and then what's happening over here. Okay, so mathematically, in just theoretical space, this is the full model we're using, but in actual application, that doesn't apply. Okay, so just be aware that that happens, but it's really out of our control. When we have a quadratic, we just have to look for those extraneous answers. Okay, let's look at another one. So this next one is practice 2 and is found on page 428. Okay, so it says the square of a number minus 8 times the number is equal to 48. Find the number. I read through it quickly because I just want to know what are we talking about. We're not talking about divers anymore. We're talking about numbers. Now when we talk about numbers, typically this turns into just a translation type of problem. So we're going to translate words into algebraic symbols and expressions. Nothing more than that. Okay, so it says again, the square of a number minus 8 times the number is equal to, I would stop there. Okay, always go up to the equal sign, translate that first half, then go to the other side and translate the other half. So again, it says the square of a number minus 8 times the number is equal to. Square of a number minus 8 times the number is equal to. Practice 2. Square of a number minus 8 times the number. Square of a number minus 8 times the number. Start to think about it and picture it in your head. Square of a number minus 8 times a number. Square a number minus 8 times the number. That's it. Did I read that once and just throw it on the paper? No. I said it again and again and again. Almost to a point where I had it memorized and I could picture it, closing my eyes, and then I write it out. Okay? Take your time with it. Don't be afraid to go through the steps. Now, that is equal to, and then we go to the other side. Sometimes the other side is just as complicated of an expression, but in this case it says it's equal to 48. Okay? So, that equals 48. And there's your equation. Whenever I have a word problem or an equation that I give you, it will be factorable eventually once you move things around. When we get into chapter 11, things won't be factorable all the time, and we'll talk about how to fix that. Okay? But right now, move it around. We got to get a 0 on one side. So we got x squared minus 8x minus 48 equals 0. Okay? Now we shift gears into factoring. This is nice because x squared is just x and x. To get a negative 48, we're going to have opposite signs. And then we need multiples of 48. So again, if you can just think of one pair that works and write it down, by all means go ahead and do that. But if you have to, 1 times 48, 2 times 24, 3 times 16, 4 times 12, 5 doesn't divide evenly, 6 times 8, 7 doesn't divide evenly, and then we're back to 8. Don't be afraid to list these. That didn't take me 5 minutes. Carry out that list if you need. And then we need what pair has a difference of 8, and that's your 4 and 12. So I've got a positive 4, negative 12. And then set them equal to 0. Oops. So I subtract a 4. And here, add a 12. And there we go. Okay, now, which one do we throw out? Neither of them. We threw out that negative 2 in practice 1 because we were talking about a time. We don't want a negative time. What are we talking about here? We're talking about numbers. Is negative 4 a number? Yes. Is 12 a number? Yes. So in this case, both of these numbers will work, and those are both part of our answer. If they specifically said find a positive number, well then we just know at the 12. But they didn't specify that, so both of these will work. Okay? Let's now move on to practice 3. Practice 3 can be found on page 429. And it goes like this. An engineering team from Georgia Tech earned second place in the flight competition with their triangular-shaped paper hang glider. The base of their prize-winning entry was 1 foot less than 3 times the height. If the area of the triangular glider wing was 210 square feet, find the dimensions of the wing. Again, read through it once, maybe twice, just quickly to get an idea of what they're talking about. They're talking about some people going to a competition and they make a triangular piece of paper that's going to glide, okay? Almost like a paper airplane, essentially. Okay, so again, let's read it and start pulling some information out. An engineering team from Georgia Tech earned second place in its flight competition with their triangular-shaped paper hang glider. We know that already. We don't have to read that again. Cross those 2 lines out. Then it says, the base of their prize-winning entry was 1 foot less than 3 times the height. Okay, so now, we're in practice 3. What 2 things did they talk about there? They talked about a base, and they talked about a height. Okay, now here's the key to this. Which did they say nothing about? It said, the base of their prize-winning entry was 1 foot less than 3 times the height. They said the base was blah, blah, blah. Okay? So that one we have to figure out. We have to decipher that. But the height, they just said height. That's it. The thing they say nothing about, that's your variable. That's your clean blank spot. Now again, the base says the base of their prize-winning entry was 1 foot less than 3 times the height. 1 less than 3 times the height. Notice how I simplified the wording there. 1 less than 3 times the height. 3 times the height, 1 less than that. All that was a translation. Okay? Now we read on. If the area of the triangular glider wing was 210 square feet, find the dimensions. So the last thing they tell us is that the area is 210 square feet. Okay? Now, that's the information that they give us. Since they were talking about a triangle, you could draw a picture of that. I personally am a list kind of guy, but you do what works for you. All you're trying to do is take all that wording out of it and write down the information that's needed in as simple a form as possible. Okay? So, base, height, and area. Now, what way can we relate all 3 of those pieces of information? Well, the formula we're going to use is that area of a triangle, which is 1/2 base times height. There's your formula that's already been established for us to use. We just need to know that that's the connecting piece that glues all this together. Now, once we have this, we're going to pull all this information here into this and then solve what we can. So the area we know is 210. The half stays. The base is 3h minus 1. And then the height is just h. It was important for us to write both of these in terms of h so that now we only have a single variable that we can solve. Now, when we go through this, there's a few different ways that you can go about this. You don't have to do this in exactly the same order that I do. Okay? First thing I would probably do is distribute. These 2 can be distributed at the same time, but just so that it doesn't combine too much, I'm going to do them separately. So I've got 210. I'm going to distribute the 1/2 to get 3 over 2h minus 1/2. And I still have that. Then I distribute that h. And we're here. Okay? Now, at this point, I don't like fractions. Okay? I'm going to clear them out. I could have cleared them out up here. However, when I see students do that right away, I see them typically over-distribute things, and they mess up the problem. That's why I like to distribute first, then clear the fractions. Okay, so to clear fractions, what I'm going to do is I'm going to multiply every term by the LCD, and in this case the LCD is a 2. So I've got 420 equals, and now watch what happens. Those cancel, and these cancel. And I've got that. Okay? Again, I multiplied every term by the LCD. In this case, it was a 2. Okay, if you don't like this cross out stuff, then just go 2 times 3 divided by 2. That'll give you that 3 popping out. 2 times 1 divided by 2. That'll give you the 1. Okay. Now I'm back to a normal quadratic. I want to get a 0 on one side, so I'm going to subtract this 420 to get 0 equals 3h squared minus h minus 420. Okay, I'm then going to have to factor. So I'm going to look for, guess and check. I got 3h and h, and I know that I'm going to need opposite signs. Now we're stuck with 420. Okay, now that 420 is a large number. It's going to be a tedious thing. However, don't just sit there and say, oh, I don't want to have to do that, because that's when you get discouraged, you waste time, and then you just throw your hands up and you just don't want to do it anymore. Just jump through the hoops that you need to, list out those factor pairs. As you know, in an orderly fashion, you'll see everything that you need to see. So 420 is going to be, I'm going to start with 1. 1 times 420. 2 times 210. 3 times 140. 4 times 105. 5 times 84. 6 times 70. 7 times 60. 8, if you divide it by 8, you're going to get a decimal or a fraction. You don't want that. 8 doesn't work. 9 doesn't work. I'm going to go to 10 times 42. Okay, 11 doesn't work. 12 times 35. 13 doesn't work. 14 and 30. 15 and 28. 16 doesn't work. 17 doesn't work. 18 doesn't work. 19 doesn't work. And that brings us to 20 times 21. And guys, when I say they don't work, you pick up your calculator and you say 420 divided by 16. Decimal. Nope. 420 divided by 17. Decimal. Nope. 420 divided by 18. And you just keep going through it that way. This doesn't have to happen all in your head. Try to do it in your head as much as you can, but don't be afraid to grab the calculator if you need. Now, I need to have one of these pairs plugged in here correctly to get this -1 in the middle. Now be careful, because a lot of people look at that 1 and they say, oh, it has to be this. Okay, but if we try that, and I go with a 20 here and a 21 here, I wouldn't put the 21 with the 3. Okay, watch what happens. I get -63 plus 20. I'm way off from 1. Okay, don't forget, we have to multiply by a 3 when we're doing this checking at the end. So we want something that when we multiply by a 3, then we have a difference of 1. And that's going to happen there. Okay? So let me try those two. 12 and 35. I can't put a 12 with a 3 because there would be a GCF. So I'm going to go with a 35 and a 12. Now watch what happens. Now, -36. That's what we want. Plus 35, -1. Okay? So don't forget that there are other components sometimes with these guess and checks. Don't just say, oh, there's a 1 and then it's going to work. Okay, make sure you're checking as you go. Now I set these equal to 0 and see what happens. So 3h plus 35 equals 0. This is an h. h minus 12 equals 0. Okay. Now, to put -35 on both sides, that's all fine. But if you feel like you're comfortable with this and you just want to say subtract 35, divide by 3, I'm okay with you doing that. Just be careful. If you find yourself making little sign mistakes, write out all that work in between. Okay. So we've got this as a possible height, and then here I would add a 12. H equals 12. Now, remember, we might have an extraneous solution here. Okay, when would we have an extraneous solution? When one of these numbers just doesn't make sense. We're talking about heights here. We cannot have a negative height. The fraction here is perfectly fine, but the fact that it's negative, no good. Okay, so all we have is a height of 12. Now they asked for the dimensions of the problem. When you think you're done, always go back and reference and see what were they asking for. They wanted the dimensions. So yes, the height is 12 feet, but there's another dimension for that base. That base, remember, is 3 times the height minus 1. So if the height we found to be 12, 3 times 12 is 36, and then that gives us a 35. So what we have is a height of 12 feet and a base of 35 feet. Okay? There's a lot going on here, but I want you to see where all the work was. Most of this work was not even the solving part, this factoring. That's where most of the work was. And factoring is old news. Okay, so don't let this kind of throw you off and discourage you, because most of this was simply factoring. Okay? It took us a long time to get to this point. That's the word problem portion of it. After that, you're just solving. Okay, let's move on to another one. Let's go on to practice 4, which is found on page 430. Okay, practice 4 on page 430. We've got find two consecutive integers whose product is 41 more than their sum. Okay. Now remember, integers are just solid numbers, and when we're talking about consecutive ones, we're talking about one after the other after the other. Okay. Now, we're talking about two consecutive integers. The first thing I always like to do is just list how many we have. If we're talking about two, we have a first and we have a second. Any consecutive integer type problem, list how many you have first, and you always start with some unknown number. If that's some integer, I don't know where I'm starting, but I'm starting there. Now, if I want to have a consecutive integer, okay, then what I'm doing is if I start at 5, then my next consecutive number would be 6. If I started at 19, my next consecutive number would be 20. What am I doing to get from the first to the next one? I just add a 1. So, if this first number is x, whatever that may be, the next one would be x plus 1. Okay? If you were looking for consecutive even numbers, or integers, then it would be x plus 2. If it was consecutive odd, it would also be x plus 2. Okay? So, we've got x plus 1. Those are our pieces of the puzzle, so to speak. Okay, those are two consecutive integers. But they say the product of those is 41 more than their sum. So let's think about that. Product means multiply. If I multiply those, that is 41 more than when I add them. The product of those is 41 more than the sum when I add them up. The word problem portion is done. Now we just have to solve that thing. First thing I always do is distribute. So I'm going to get x squared plus x. And then here I can combine like terms. I've got 2x plus 42. Okay? Now I want to get a 0 on one side. I always like to put the 0 on the side where the x squared term will be positive. So I'm going to bring these over to the left. So I'm going to subtract 2x. And then subtract 42. And we got that. Okay? Now, at this point, we just shift to factoring and then go from there. So if we're going to factor this, I am going to do some guess and check. And I start out really nice because it's just x and x. And a negative 42 is going to need opposite signs. Okay? And then I need two numbers that multiply to a 42. So that could be 1 and 42, 2 and 21, 3 and 14. 4 doesn't go into 42. 5 doesn't go into 42. And then we've got 6 and 7. Okay? Those are our options. That's it. Now, since there's no number here, we can just say which of these pairs have a difference of a 1, or in this case a negative 1. And that would be the 6 and 7. So, since it's a negative 1, I'm going to go positive 6, negative 7. After that, set those equal to 0, go from there. So I've got x plus 6 equals 0, x minus 7 equals 0. I would subtract a 6. I would add a 7. And we have those. Okay? Now, a lot of people look at the 6 and 7 and say, oh, those are consecutive. Those go out one after the other. However, it's a negative 6 and then a positive 7. There's a big gap between those two. We just found two different integer values that could represent that initial x. So x could be negative 6 or 7. It could be one or the other. Now here's where we got to be careful, because this then gives us two sets of answers. Okay? So if I started at negative 6 and then I add a 1 to get to the consecutive integer, it would be negative 5. So my two consecutive integers whose product is 41 more than their sum could be negative 6 and negative 5. Or another pair would be 7, x plus 1 is 8. When you write this answer, in some way show that these two go together or these two go together. It's not I have just 4 random numbers. It's this pair or this pair. Okay? Even if it means you're circling them like I did there, do something to show that it's one pair or another pair. If the problem asked specifically for positive integers, well then this would be gone. Or specifically for negative, well then these would be gone. But in this case they didn't. So all of those would be appropriate solutions. Okay? Let's do one more. This is found on page 431. This is practice 5. Okay, practice 5 says, find the dimensions of a right triangle where the second leg is 1 unit less than double the first leg, and the hypotenuse is 1 unit more than double the length of the first leg. So again, read through it once just to get an idea of what things they're talking about. They're talking about a right triangle. Okay. Now, with a right triangle, remember what makes it a right triangle is that you have a right angle in there. And then there's two main components to a right triangle. There are the legs that form the right angle, and then you have your hypotenuse. Okay? Your hypotenuse can be identified as the longest of the three sides or the side opposite the right angle. Okay? Now, they describe those sides. Okay? They say again, find the dimensions of a right triangle where the second leg is 1 unit less than double the first leg. So again, they mention a first and a second leg, but they say nothing about that first leg. So if I'm going to call this my first leg, it doesn't really matter which is first, which is second. Okay, but if this is my first leg, I know nothing about that. It's x. That second leg, again, is 1 unit less than double the first. So 1 less than double the first. So I'm going to double that first leg and lessen it by 1. The hypotenuse then is 1 unit more than double the length of the first. So 1 more than double the first. 1 more than double the first. Okay, so I doubled it and then I increased it by 1. Over here I doubled it and I decreased it by 1. Now, those are the pieces of the puzzle. How do we pull all that together? Well, here they don't, like in that glider problem, they say the area is. Here they don't give us an all-encompassing unit of measure. But here what we have is a right triangle that follows always that Pythagorean theorem. A squared plus b squared equals c squared. I'm sure you all have heard that before, but just as a review, this theorem right here tells us that if we square one leg and then add to it the square of the second leg, that should equal the square of the hypotenuse. Okay? Which leg is A, which leg is B does not matter as long as the hypotenuse goes here. So what we have is the first leg was x, I'm going to square it. The second leg was 2x minus 1, I'm going to square it. And then the third, the hypotenuse, not the third leg, the hypotenuse is 2x plus 1, and I'm going to square it again. Okay? Now, that's my equation. There's a lot of stuff to do still, but that's my equation. Now, first thing, distribute. If you can do it in your head, great. If not, I would take 2 seconds and write these out twice. If you can just visualize another one next to it to do the foiling, great. But if not, again, that only took me a few seconds. It makes it a lot easier to do. So I'm going to then FOIL all this out. So I've got x squared coming down. Then I FOIL these. I've got 4x squared minus 2x plus 1 equals 4x squared plus 2x plus 2x plus 1. Again, before you move on, you double check all of that. You don't want to do 3 more steps and realize, oh, this was wrong the whole time. Okay? So, next I would combine like terms. I've got 5x squared minus 4x plus 1, 4x squared plus 4x plus 1. And now I need to get a 0 on one side. And like I said before, I want to get it on the side that will leave the x squared term positive just to make the factoring a little easier later on. So I'm going to get all this stuff over to the left. If you want, you can do this all at once. I'm moving the x squared term. I'm moving the x, the linear term. And then I'm moving that constant term. If that's too much for you, then you do it one at a time. Just do what's comfortable. Okay? All of that cancels out by design. I made that happen. And then I've got x squared minus 8x, and that goes away as well. That's a wonderful thing to see. Because this factoring now, you don't need guess and check. It's just take a GCF out, and I'm good to go. So x equals 0, or x minus 8 equals 0. I would add the 8, and I get those 2 answers. Now, whenever you have something tangible in front of you, always worry about those extraneous solutions. Okay? In this case, I don't see any negatives. However, I do see a 0. Okay? This x represents one of the sides of that triangle. Can I have a side that's 0? No, because if I did, then that triangle would just shrink down to a single line. That's what we would call a degenerative triangle. Okay? It just goes away. I don't want that. So this is gone. The only thing I have is that this first leg is 8. So I have 8 as my first leg. My second leg is here. If I take 2 times that x, I get 16. 16 minus 1 is 15. Then, for the hypotenuse, I take twice that x. 16 again, plus 1 is 17. And there are my dimensions of that right triangle. Okay? That concludes this section 6-7. Do not take this and try to finish it quickly. Take your time. If that means you have to look at an example 3 times before you move on, you have the luxury to do that with these videos. Don't be afraid to pause and then rewind and listen again and again. Okay? Remember also there are examples that are spelled out for you in the textbook as well. So like at practice 5, there's a example 5 that is just like this that's also spelled out and solved for you in the book. Okay? So what we have out of our 5 examples, we talked about, first of all, there was that cliff diver. I want you to think of that as a problem that has an equation given to you. Plug it in, solve it, you're good. Then we had that number problem where we were given an expression in English language. We just had to translate it. So equation given to you, translation, number problem. Then we had that paper hang glider problem. The issue with that one was we had that really long factoring. Take your time with it. Okay. Also, the initial layout of that was list the pieces you have. You had base and height. I listed them. I translated them nicely. Then I pulled them together. After that, we did that consecutive integer. Same thing. I list. Then I pull it together. Then we had this. I list. And then I pulled it together. Okay. There's a lot of repetition within this section. So again, try to generalize those lines of attack, okay, and those strategies that we had here. And then later on, if you're given a problem in your field or at your job that gives you a lot of information, list it, pull it together, okay? As always, work hard, ask me questions if you have any, and I'll see you later.